Alright, hi guys. So normally we would start and I would go over all of this do now. But 1 through 4, your brainstorming for 1 through 4 is actually going to go into the first page of our new packet. So I'm just going to skip all the way down to 5. Number 5 is on here because number 5 was one of the most mistaken, I guess, questions on the do now, or on your quiz yesterday. It's one of the topics that a lot of people messed up on. So those are the ones that we're going to be really focusing on and kind of weaving back into those. So for here, you had wanted to do keep, change. So when you go ahead and try to do keep, change here, what should be happening is that I have what I need. Okay, so 4 plus x, 4x plus 2, is that keep. So you're keeping this 4x the same, you're keeping the plus 2 the same. From here, you're changing the minus to a plus. You change negative 5x to positive 5x, and minus 8 to plus 8. Okay. From there, you have two options. Option number 1 is to either box and circle. So you would box in the 4x and then box in the plus 5x. Okay. So those are the two you're boxing. I'm just going to change the colors of them since I can't really box on the computer like I would like to. So 4x we have here, and then plus 5x, you would box everything before that, okay? So those are the two numbers you're going to add together. Okay, so we have 4x plus 5x. So you just add your numbers, and you get 9, and you keep your x. Okay. From there, you're going to look at what's left. So you have plus 2, or a positive 2. We use holiday colors. And then plus 8. So 2 plus 8 is going to give you 10. So it's going to be plus 10. You have to combine like terms. You can't do 4x plus 2 is 6x. A good amount of you, I don't want to say a lot, but a good amount of you still did that. And a good amount of you now tried to go on with this problem and say that that's 19x. That is not 19x, okay? This 9 here, this is like saying I have 9 teachers, and then I have 10 desks in a room. I don't all of a sudden, those 10 desks don't morph into teachers. If they did, you would have different problems right now. So those stay as 9 teachers and 10 desks. They don't merge together. It doesn't become 19 teachers. Those 10 desks don't transform into teachers. They stay as desks. So you have to keep them separate. A lot of people kept saying, do I have to solve this? You are not solving anything that doesn't have an equal sign. Yes, mine does. That point. All you're doing, you keep 9x plus 10. That's okay that there's two terms in your answer. You don't always just need to have one term, one number, one little smush of numbers for it to be correct. It's okay that there's two terms there. 9x plus 10, that is it. That is what is equivalent. That is what we're looking for here, okay? So, moving on from that, I spent like 3 minutes on that one question, but it was necessary. So we're moving on, and we're going to look at that packet, so don't mind me while I jump back and forth, okay? So here, this is that front of your new packet that you picked up today. If you don't have this in front of you, go ahead, go over, grab it on top of the Chromebook cart. You will need it. So, I'm not trying to save it. So, okay. So some vocabulary here is already filled in for you. So we have variable, which is a symbol, such as a letter that represents a number. So basically it's a placeholder. So we've talked a lot about variables lately already because we were combining like terms. So we've talked about variables. Equation, statement of equality, equal. Okay, equation has an equal sign. Number sentence is a statement of equality between two numerical expressions. So 2x plus 4 equals 5. Okay. Solution. A solution to an equation. So the equation had an equal sign with one variable is a number that When substituted in for the variable in both expressions, it makes the equation true. So basically, the solution is a number that when you plug it in to your equation, both sides of your equation are equal. They balance out, okay? So moving on from there, we have this chart. This is what we're going to fill in. So yours doesn't say this. Don't write that. We want to write equal in here because that's what we want to do. So I'm going to start with the words that mean equal. I don't want to ask you to fill those ones in, but that's okay. So equal, we only really have two words we're going to use here that mean equal. First one is equal. You can rewrite that if you want. You don't have to. Equal. And then we have, what's the first word? Hold on. I lost my page. I went in the wrong order. So equal. Sorry, we have three words. Equal is and thing. That you apparently can't read. Okay. Equal is and thing. Those are the words you're gonna use that mean equal. So if I say 7x is 10, it means 7x equals 10, or the total is 10, or 2x is the same as 11. That means equal as well. Okay. So we're moving over here to addition. So if you have words that I don't have on here and you want me to check them, raise your hand. I'll check them, obviously, as usual. Make sure they are words that are allowed to be on there. So starting here, for adding, you have plus, you have sum, and total, increased by. You also have, whoops, I don't know what just happened. I'm doing good with technology today, in case you're wondering. You also have added to. That's all. And we have more than, so 3 more than something. So these two are special. First, I'm going to just highlight all these. Okay. So this one and this one, I would highlight them, star them, circle them, do something. These are special. Okay. These are special because when you have these in a problem, it means you're going to switch the order. Okay. So if I'm saying 7 is added to 5, it's going to be 5 plus 7, not the other way around. So yes, addition is commutative, but if you're translating an expression, which is what we're working on, so going from words to numerical sentences, you have to get it in the right order for it to be correct. Okay. So subtraction, we have minus, take away, difference, subtracted from, that's a special one, less than, last one over it, up here. Taken away from. Okay, so taken away from, subtracted from, and less than. Those are your special ones again. Okay, so make a note, star, highlight, whatever. Those mean to flip the order. If I am, I don't know, let's see, if I am 6 inches less than Billy, you're going to take Billy's height and subtract 6 inches from that, okay? So multiplication, we have times, apparently ims, times multiplied by product of, okay, double, which is just times 2, and triple, which is times 3. You can also do quadruple and etc. So none of these are special ones that changes the order of them. I'm just going to put them in a different color so it's nice and pretty to look at. Okay. Last one, division. So you have, if they talk about putting something into equal groups, you have quotient that you learned a little bit back. Split by, or split into. Divided by, obviously, into, which is going to be your special one. We'll go back and highlight it after. Half divided by 2. And then third would be like saying divided by 3. Okay, so into was your special one. But so are half and third. So if you say you want half of 7, you're going to do 7 divided by 2. Okay? So these highlighted ones, those are your special ones. Those are the ones that the order flips. So make sure you make a note of that somewhere, maybe on the bottom. Whoops. I can't get the formatting to work the way I want it to today. So maybe down here, highlight it, you say highlighted means flip order. Flop order. Okay, wherever you want to write it, as long as you spell it correctly. I don't think I spelled highlighted correctly. Highlighted. So it's good to have somewhere. It doesn't matter where you write that, but I would make that note somewhere here. Okay, so this chart you should have filled out. You should have notes written for all those that I have highlighted. From here, we are moving on to this sheet here. Okay, so you do not have this. This is something you don't have, and that's okay. So we're going to be using these words. So we have 4 less than a number. So less than means to flip the order. The number we're just going to call x. So x. And then we're going to do minus 4. So what happened here? 4 less than a number. The number we called x. So we're doing 4 less, so we're doing minus 4. Okay? 8 more than a number. More than means flip. So x plus 8. Okay, I'm not going to finish all of them. Skip down a couple. 3 times a number. So 3 times x. You can write it like that. Or you can just write it 3x. If you wanted to choose a different variable here, that's fine. Use another letter. That is all good. Okay. 7 less than the opposite of a number. So you have the number x. The opposite of that is making the sign different. So negative. Then you have 7 less than that. So less than means flip. Okay. I'll do one more. I'm going to do the one all the way down here. The opposite of the quantity of 3 less than 2 times a number. Quantity means parentheses. 3 less than 2 times a number. So 2 times a number, then 3 less than that, and then the opposite. Right? So that one was a complicated one. That's why I wanted to do that one with you. Okay. So from here, either pause this video now, so you should have these, you want to write these down on your paper. Either pause this video now, complete these ones, or move on, keep going with the video, watch the next one. Those ones are equations. This was expressions, because there's no equal sign. And we're moving on. So you do want to complete these when you're done with the video. So here, translating equations. 2 more than 3 times a number equals 11. 2 more than 3 times a number, so 3x, 3 times a number. 2 more than that equals 11. Okay. 5 times the quantity of 1 less than 2 times a number. So 1 less than 2 times a number, 2 times a number, 1 less. And then 5 times that, so let's put a 5 up front, equals 25. Okay. So I'm going to stop here. You are going through and completing all of these, though. If you need help, raise your hand, call me over. I am here to help you.